Bismillahirrahmanirrahim. Assalamu alaikum dear students. I, Ms. Satya Naseem, on behalf of Garrison Academy Senior Campus, welcome you all in EBSEX online support program. This is week 3, day 2 of our chemistry lesson for class first year. Students will continue with unit number 2, atomic structure. The objective of today's lesson are you will be able to understand discovery and properties of canal rays, discovery and properties of neutrons, discovery of nucleus, derivation of radius of an orbit of hydrogen atom. Students, let's understand the discovery of proton or positive rays or canal rays. Protons were discovered by Goldstein, who was a German physicist in the year 1886. Let's understand the construction. He used 1 meter long discharge tube. This discharge tube was provided with perforated cathode. Perforated cathode is a cathode containing holes in it. Or we can say that perforated cathode is a cathode containing canals. Canals means holes or openings. Cathode was connected to the negative terminal of the battery and anode was connected to the positive terminal of the battery. Means the electrodes were connected to a source of high voltage. The atom which was present, we know that the atoms are electrically neutral, means the atom contains same number of positive and negatively charged particles. We can say, in other words, the atom contains same number of protons and electrons. In this discharge tube, ionization of gas takes place. For example, if neon gas is used in a discharge tube, neon gas will lose one electron and it will be converted into a positively charged neon ion. So students, let's understand the working. When an electric current was passed through a gas which is maintained at a very low pressure, it was observed that some rays were produced from cathode that traveled away from cathode, and these are the cathode rays. These rays can ionize the gas which is present in the discharge tube. These rays can knock out the electrons which is present in the gas, and the gas is converted into a positively charged ion. So positive ions were produced, and these positive ions start moving towards the cathode because they are positive in nature. The positive ions which were produced by cathode, these positive ions start moving towards the perforated cathode, and these positive ions, after passing through the holes, it was seen that they produced a red glow on the wall of the discharge tube. So the cathode rays travel away from cathode, and the positive ions that are produced, or the positive rays, they travel towards the cathode, that is away from anode. So let's consider a general gas which is represented as M. When this gas loses an electron, it is converted into a positively charged ion. For example, if helium gas is used, it contains 2 electrons, and the helium gas loses its 2 electron to produce a positively charged helium ion. Students, let's discuss the properties of positive rays. It's very clear in this diagram. This is anode. It is connected to the positive terminal of the battery. This is perforated cathode. It is connected to the negative terminal of the battery. Some rays are produced from cathode. These are cathode rays that travel away from cathode. These cathode rays can ionize the gas molecules that are present in the discharge tube, and these gas molecules are converted into a positively charged ions. These positive rays then pass through the holes which are present in the cathode, and they produce a red glow on the walls of the discharge tube. So students, first property is they travel in a straight line. These positive rays travel in a straight line perpendicular to the anode surface. This is the anode surface, and they travel in a straight line perpendicular to the anode surface. Point number 2, if these positive rays are brought in an electric field, for example, this is a negatively charged plate and this is a positively charged plate, then these positive rays are always deflected towards the negatively charged plate because they are positively charged, means they are deflected in electric field. Point number 3, these rays are always deflected towards cathode because they are positively charged. Next point, they produce flashes on zinc sulfide plate. When a zinc sulfide plate is placed in their path, the positive rays produce flashes on zinc sulfide plate. Next point, the charge to mass ratio is smaller than that of an electron. Basically, these positive rays are the protons, and when we calculated the charge to mass ratio of proton, the answer was 9.5 into 10 raised to the power 7 coulombs per kg. And we have calculated the charge to mass ratio of an electron, and the answer was 1.7588 into 10 raised to the power 11 coulombs per kg. So we can see that the charge to mass ratio of a positively charged particle is less than charge to mass ratio of electron. If hydrogen gas is used in a discharge tube, then this hydrogen gas, the hydrogen atom which is present in the hydrogen gas, will lose one electron and it will be converted into a positively charged hydrogen ion, that is proton. If neon gas is used in a discharge tube, for example, then this neon gas will lose one electron and it will be converted into a positively charged neon ion. So the positive particle is different for different gas, and so we can say that the charge to mass ratio depends upon the nature of the gas. If we calculate the charge to mass ratio of hydrogen and if we calculate the charge to mass ratio of neon, it will be different. Why? Because mass of this hydrogen ion is different from the mass of neon ion. So if the mass is different, then the charge to mass ratio will also be different. So we can say that the charge to mass ratio depends upon the nature of the gas that is used in the discharge tube. For example, in case of hydrogen ion, the charge which is a lighter, it is a lighter gas. Hydrogen gas is a lighter gas. When a lighter gas is used in a discharge tube, then the charge to mass ratio will be greater. Remember, students, if a lighter gas such as hydrogen is used in a discharge tube, then the particle which is produced from the hydrogen gas is the lightest particle and charge to mass ratio will be greater. Why? Because the mass is less. The mass of this positively charged particle which is produced from a lighter gas, that is hydrogen, is less. When the mass is less, then the overall answer will be greater. If some heavy gas is used, for example neon, then the positive particle which is produced from neon is Ne+1 and charge to mass, this is a heavy gas, which is if a heavy gas is used in a discharge tube, then the positive particle which is produced from a heavy gas, it is also a heavy particle which is produced and the mass will be greater. When the value of denominator is greater, then the overall value will be smaller. So we can say that charge to mass ratio of a heavy gas is smaller and charge to mass ratio of a lighter gas is greater. Next point, the mass of the positive particle is never less than that of proton. When the mass was calculated, when the mass of the positive particle was calculated, it was seen that the mass is not less than that of a proton. The mass of the positive particle is never less than that of proton. It is not less than that of proton. So this positively charged particle was called proton, and this name was suggested by Rutherford. The particle obtained from the positive rays. These are the positive rays, and the particle that is obtained from the positive rays is called proton. And students, last point, we have calculated the mass of proton in our previous lecture, and after the calculations we have seen that the mass of proton is 1833 times, or to be exact, the mass of proton is 1836 times more than that of electron. We have calculated the mass of proton in our previous slides. Yes, friends, so let's study the discovery of neutrons. In 1920, Rutherford predicted that some neutral particle must be present in an atom. But why he predicted? Why he predicted that some neutral particle must be present? Because according to Rutherford, the atomic mass of an atom cannot be explained if we suppose that the atom contains only proton and electron. In order to explain the atomic mass, some neutral particle must also be present in an atom to explain the atomic mass of an atom. Because we know that the atomic mass of an atom is equal to the number of protons plus number of neutrons. So an experiment was conducted by James Chadwick in 1932, and he was awarded Nobel Prize in Physics for his experiment in 1935. So let's study what was his experiment. He used a polonium source. Polonium is a source of alpha particles. Alpha particle is a helium nuclei. The polonium was enclosed in a lead block. The lead block allows the radiation to pass from one side only. So, a stream of alpha particles were produced from polonium. How these alpha particles are produced from polonium, we can study the reaction, and the reaction is the polonium atom decays to produce alpha particles and lead nuclei. In this way, the alpha particles are produced from polonium. The alpha particles was directed on a metal foil, and this metal foil is beryllium. It is a target metal, and the alpha particles were directed on this target metal foil, that is beryllium. And it was noticed that these alpha particles, when they were targeted on beryllium, they produced neutrons. The neutrons were produced, carbon nuclei was also produced, and neutrons were also produced. And when these neutrons were directed on paraffin wax, or we can say candle wax, these neutrons were able to knock out protons from the paraffin wax, and when these protons entered a chamber, which is a gas filled chamber, the gas was filled in this chamber, these protons were able to ionize the gas which was present in the chamber, and the detector was connected to the chamber. This detector can detect the presence of positively charged and negatively charged particles, and the detector could detect the protons that are positively charged particles, and this detector showed that the neutrons are neutral particles carrying no charge. So what did James Chadwick noticed? It was noticed that some penetrating radiations, neutrons are penetrating radiations that were produced. These radiations were called neutrons. Because why they are called neutrons? Because the charge detector showed them to be neutral, because they are neutral particles, and the detector showed that these particles carry no charge, they are neutral, so they were named as neutrons by James Chadwick. I hope, students, the experiment is clear to you. One more thing, students, the atomic mass which is given on the left side of the equation must be equal to the mass which is given on the right side of the equation, and same is the case with atomic number. For example, the atomic mass of helium is 4 and that of beryllium is 9, so 9 plus 4 is equal to 13. So 12 is the mass of carbon and 1 is the mass of neutron, so it is balanced. Same is the case with atomic number. The atomic number of helium is 2 and that of beryllium is 4. So 4 plus 2 is equal to 6. So it is balanced on the right side of the equation as well. Neutron has a charge of 0 and mass 1. Students, let's understand the properties of neutrons. Point number 1, free neutrons decay into proton with the emission of electron and neutrino. Proton has a charge of plus 1 and mass of 1. This is a beta particle. It has a charge of minus 1 and mass 0. This is neutrino. Its charge and mass is 0. Next point, they cannot ionize gases. Neutrons are non-ionizing in nature. They are highly penetrating particles. They can penetrate into the material on which they fall. Next point, when neutrons travel with energy 1.2 mega electron volt or more, they are called fast neutrons. And when they have energy below 1 electron volt, they are called slow neutrons. Next point, they are not deflected in electric and magnetic field because they are neutral in nature. They can knock out high-speed protons from paraffin, that is candle wax, water, paper, and cellulose. Slow neutrons are more effective. They are more useful than the fast ones, and they are more effective in the fission process. For example, this neutron is absorbed by uranium nuclei. After absorbing a neutron, this uranium nuclei is converted into an unstable nuclei. This unstable nuclei then produces 2 stable nuclei and 3 neutrons are produced. These and in this fission process, a large amount of energy is produced. These neutrons can further carry out the same reaction. So these slow neutrons are very effective in the fission process. When neutrons are used as projectile, means when fast neutrons are used, they can carry out nuclear reactions. Nuclear reactions are reactions in which the nuclei is broken down. For example, when fast neutron is used in a nuclear reaction, this neutron can eject an alpha particle from nitrogen atom and a boron atom is also produced. When slow moving neutron hits the copper metal, then beta radiations, that is beta particles, are produced. Because of their intense biological effect, means they can destroy the cancer cells. They are used in the treatment of cancer. Students, let's study the discovery of nucleus. When electrons, protons, and neutrons were discovered, the next problem was to locate the position of these subatomic particles. Rutherford performed an experiment in 1910. He used radium or polonium as a source of alpha particles. He bombarded alpha particles on a thin gold foil of 0.0004 centimeter thickness. He observed that some alpha particles passed straight through the foil, some alpha particles were deflected through some angle, and some alpha particles moved in the backward direction. So, this is the diagram that explains the deflection of alpha particles. Some alpha particles passed straight through the foil because most of the space occupied by the atom is empty. Some alpha particles were deflected through some angles because these alpha particles were deflected by electrons, and some alpha particles were deflected backward because these alpha particles were deflected by the nucleus of an atom. So, what were the conclusions drawn by Rutherford? First one, an atom consists of a small, heavy, positively charged portion called nucleus. A negatively charged portion is also present. around the nucleus that contains electrons, and this portion, this negatively charged portion, is known as extranuclear portion or planetary. The portion in which electrons are present, that portion is known as extranuclear portion or planetary. Third postulate, the number of protons in the nucleus are equal to the number of electrons in the planetary. The electrons revolve around the nucleus, as we can see in this diagram. The centripetal force is equal to electrostatic force. The centripetal force with which the electrons revolve around the nucleus is equal to the force which is present between the nucleus and the electron, that is the electrostatic force of attraction. Only a small volume is occupied by a nucleus. Rest of the space is empty. So students, there were some defects in Rutherford model. According to classical electromagnetic theory, an electron, while revolving around the nucleus, must radiate energy continuously, and in doing so, the electron must be accelerated towards the nucleus, and the orbit will become smaller and smaller, and the electron will fall into the nucleus. This will collapse the atomic structure and the atom will not exist, but this does not happen because atoms are all time existing. The second defect was, if electron emit energy continuously, then a continuous spectrum must be formed, but it was observed that continuous spectrum is not formed, line spectrum is formed. So these were some of the defects of the Rutherford atomic